Question number 3. What is the critical value of f? Okay. So this is f distribution, kind of, and critical value f. Critical value depends on the degree of freedom within and degree from between. So let's see. So degree from between is, because there are 1, 2, 3 groups, so df between is 3 minus 1 is 1, right? 2. Degree from within is 1, 2, 3, 4, 5, 6. So degree of freedom for this is 6 minus 1, and same way for this and that. So 5 plus 5 plus 5 equals 15. That's a degree of freedom within. Okay, so 2 and 15, using those values, degree of freedom within between was 2, so this degree of freedom within was 15, so that, so 3.6823. .6823, that's gonna be a critical value of f. So in this f distribution, if the f statistic falls into this region, then it means it didn't happen by chance. Therefore, we reject null hypothesis that there's no difference. The difference, we can conclude that the difference was due to the actual differences found in between groups. So okay, well, let's see, critical value 3.6823, and f statistic we got from this was, let's look at the previous. Okay, f was 8.06. Oh, what a 8.06. So which was maybe here 8.06. So that means, do you reject or fail to reject null hypothesis? So that means you reject the null hypothesis. As I said, there was these differences here, differences of means, that was not due to sampling error, that was actually due to the actual difference between these groups, because the chances of this happening is so slim. This is the chance of this happening so small. It's probably like a 0.00 something, percent of happening that these differences could occur due to the sampling error. So okay, that's why we kind of have to conclude that there was actual effect, not the effect, actual differences in between the groups. Question number 5. Calculate and interpret the R2 value. R square. R square is for f statistics is effect size, just like a D colons D for t-test. So how do you do effect size? As I remember, it is this sum squared between divided by sum squared total. So basically, sum squared between is this. Sum squared total is this. Total is a combination of sum squared between and sum squared within. So sum squared between and sum squared within, these are a total variations that you found in the samplings, all these scores. And by doing this calculation, you can kind of tell that the ratio of sum squared between sum of all the variations between groups. When you calculate the variation based on 3 different groups, or calculating the variations as just one big huge group, and it's the total, and you can kind of tell the ratio. From these numbers, it's kind of hard to guess the ratio. So what you're trying to do is get actual ratio. So how many percent this this value is going to be, how big is it in relation to the whole thing. Okay, so that's what it's trying to do. And of course, the value, if the value is bigger, that means this value was big. So if the sum between group differences are huge, then of course the effect is going to be big too. That's what effect size is all about. So let's do this calculation. Okay, R2, that is a sum square between divided by sum square total, and the sum square between was, as if I go back to the previous, okay, sum square between was 4.37, and so 4.37, oh, 4.37, and total was a combination of 4.37 and 4.01. Was it 4.01? Oh, 4.07. Okay, so this is the within group, right? So okay, so total is gonna be 8.44. That's the sum square total. 8.44. Okay. 8.44. And let's do calculation. .37 divided by 8.44. I got the result, which was 0.51752. Okay, let's see. 0.52. Okay. And is it big? Is this effect size large, small, or medium? Okay. You know, 0.1 magic numbers. There are three magic numbers: 0.1, 0.9, and 0.25. Okay. What it means is that 0.01. That's what I mean. 0.01. Okay. And obviously 0.25 and larger is a large effect, and 0.09 and larger but less than this is medium, and 0.01 and larger but less than this is small effect. So in this case 0.01, this is small. 0.09, this is a medium, and 0.25, this is a large. So where 0.052 is going to be, it falls into this category. So it's a large effect.